Then welcome everybody to this short or maybe long presentation. It's 1 hour is too much. But you mentioned the name of the Annex 38. It's the ground source de-icing of infrastructure. And here is important to know that de-icing and the snow melting, maybe we are going to talk about that a little bit, that there are different things. And then the overall goal of this annex was that using geothermal energy for de-icing and snow melting, and especially for infrastructures. However, in the following slides, you can see that we have not taken just infrastructure into the account. We have done, we have looked at all de-icing systems that have been available overall in the countries that were involved, or other countries that they were not involved in this annex, they have reported to us that what they have. And the systems are many, and the heat source varies in different cases, but still it's a good starting point to see that how these systems could be used and in which application, especially if we use geothermal energy. The picture, as you know, that shows that the temperature of the ground is always warmer than the air, almost. Not during the summer, I am thinking about the winter. But here, maybe we should have in our mind that these systems that we are talking about, de-icing, I'm going to take a kind of short notation about that. We can use for cooling also, cooling of pavements. We will see, we are going to see that what we have for application there. The motivation that, as you know, there is a number of these systems overall in all countries, but generally they have heated by electricity, by electric cables. The intention and the main goal and motivation of this annex was that to changing from a transition from electricity to the renewable heat by using the hydronic pavement system. This hydronic pavement system you maybe have in your home also, in your bathroom or in the kitchen, or some heating systems are based on the hydronic heating. And you have two alternatives, the electrical cables that you see up there, or you are circulating warm water in the flow. It's the same technique, but a little bit when we are going out to the pedestrians or parking area or so on, then the demands for mechanical pressure and so on changes. Then what we are focusing on is using a hydronic pavement and using the renewable energy, especially from the ground. However, what is more interesting in this case that it is not usual, it is usual, but people have not used it so much, is that the pavement itself, let me, if I can choose a good pointer, the pavement itself, especially here is a kind of piece of the road or something like it could be any kind of the surface that exposed to solar radiation, especially outside. When we are talking about the flooring at home, they are not exposed to the sun. You can use this surface when you are outside of the house as a kind of solar collector. What it means is that when they are becoming hot, you have your hydronic pavement, which means that the temperature in these pipes are higher than ground, and you can send this harvested energy to the ground to increase the temperature of the ground. And when we have it, this kind of harvesting, then you need a kind of a storage. You should save it somewhere in order to use it during the season, during the winter, which means that we have a seasonal storage capacity here also. It is the major deviation from the floor heating in the housing, that we are using the surface of the pavement as the solar collector. And then we are talking about the storage. The type of storage is not, it is important depending on that where you are and what geological condition you have, or what is the budget of the project. But you have this typical energy storage types as borehole. TTES is a tank storage, peat storage, or aquifer. Don't forget that there is a kind of, this system also could be used and have been used in the rural area. When we are talking about the thermal storage, it's especially when you are outside of the cities, maybe in vicinity of the cities. But if you have in your country district heating system, then you can use the return temperature of the district heating system in order to heat up your roads or your pavements. That we have done in Sweden in a kind of in the highway, we have done it by return temperature. And it's a highway that they are heating up that. And it have been used for because the slope of the road is too much and all lorries stop there. And during the winter, we have the huge problem with traffic and the congestion of the road. Okay, we have all of this. We have our systems, and what we want to do is almost something like this. It's a kind of prototype that we have done in Sweden in order to show to our road administrator, public road administrator, that it is possible to do. And you see here that we have different components. We have this area that I am pointing now we have the hydronic pavement here. And then the blue area is our reference area, that we are looking at what happens if we have the hydronic pavement and if we don't have hydronic pavement. Furthermore, you see that we used boreholes because the geological condition in Sweden is very suitable for boreholes. Then we used 4 boreholes. We have a service building and we have a weather station. And finally, we have sensors that giving us signals that when it is cold or when we should start the system, because controlling the system is very important. It is the whole system that we have worked with. And then we have some cases in the world that they have used almost the same system, the same components. It is not so unique, but in order to validate that and to learn how you should control, then you should do this kind of prototypes to do things that you want to do in order to find out what is the challenges. Then I hope so that you are familiar at time being with the system that I'm going to talk about. But it is not just this system. Think about that the heat source could be different, the pavement could be different, and the controlling could be different. The applications that we have used here is for road, but any pavement can be used almost the same principle for doing the de-icing. And they have done it in the world by cables, electrical cables. The structure of the Annex 38, then we are going to the Annex. We have divided it in 4 subtasks. The first subtask is about the market potential and state of the art. And it's led by Sinkel from Sweden. In the second subtask, we are looking at the modeling, how we should do that. I'm going to show you what is the challenges. And it is led by Diana Falcarini. And subtask 3 is development of the system, that what we can do that the system perform better. Then we have the Wim and Tarher from Belgium. And finally, planning, construction, and monitoring led by Sweden. It was not me in the beginning, it was one of my colleagues. Now I have another colleague that's helping me, but I decided to write my name just because one of them is sick at home and the other one have left us to industry. So this is the structure of the annex. And I'm going to present the outcomes of the annex, that what we have done. At here you see that how many countries actively have been involved. It's for 5 countries: Sweden, Turkey, Belgium, Germany, and Italy. However, we got help from Japan and United States. And there's other countries that they have contributed, but their contribution was so limited that I believe so that it is not necessary to write their name, but there's a number of countries that showed interest. Furthermore, as you mentioned, Jan, that we have produced about calculate 9 different reports. We have the subtask 1, 2, 3, 4, and from 1 to 3 we have 2 reports, and in subtask 4 we have 3, and we have delivered everything. However, because we should write a kind of summary report, because don't be afraid from what I'm saying. These reports totally are about 570 pages. Then I'm going to write something about 50 pages in order to be more readable, maybe, if you are just interested, not want to go to the deep. It is what I have done it, but it's under review, and I'm going to do some changes there. Furthermore, we have written a number of papers. We can find them in the Google Scholar or in the Scopes. It's about 6, 7 papers that have been presented in TRA, Transport Research Arena, and then in NSTOC, and then furthermore in heat and ground source conferences. And one specific topic that we were not aware from the beginning was the injury reduction of this type of the de-iced pavements. And here, okay, we can say that we know that it is possible, but in this case, a PhD that I believe so that he is done now, he showed with the numbers that by using this de-iced pavements, how many percent injuries reduces where they have used it in Sweden and other countries. And in some cases, the number of this, the percentage was so high, above 70%, above 80% reduction. And it is very good because we are reducing, it is things that we don't generally count in the sustainability or economical feasibility. We are just focusing on that, how much it costs to build and how much we are going to gain and when is the payback. But this type of the things that we are reducing the cost for the hospitals and so on, or when we are in the other cases, it is one of them. The other cases that we are increasing the mobility. I mean that when you are getting stopped in the traffic, you are losing your time. But if the road was de-iced or the prepared for mobility, as accessibility was high, then you're not going to lose that. All of these kind of benefits to society have not been calculated. It is very difficult to calculate. We just can mention, and we hope that some policymakers, they are showing interest for that it is possible to do things. Yeah, let's go to the subtask and what we have done there. Here is the market potential and state of the art. For the people who are listening, I hope that they are from different countries. We have the state of the art of the 6, 7 countries, that what they have. And it is, when I said that the number of pages is 570, maybe 200 pages about the state of the art in these countries. That they are showing that they have a football field, they have pavements, they have roads, they have bridges, name it, all the application. And it was a huge job, and we got help from many people from other countries that they were not maybe by themselves involved in activities that we have, but they reported to us that what they have. The second is the market potential. It is what we have tried to show that it is good to have it. However, as I said, it's very difficult to calculate the other benefits. As I mentioned, these systems have been used and are going to be used in many different applications. If you look at here, these railway switches is one of them. We have some cases in Germany. Ramps, stairs, and entrances is the other one. The most maybe interesting one is the parking slots, lots in front of all markets and malls. We have aircraft parking area in Sweden, road parts, tunnels. But you see that the number of applications is not limited. If you need a de-icing for increasing mobility or not getting injured or not getting the damages to your devices, then you are going to use a kind of heated pavement. And we have all these applications in our state of the art in different countries. The people, I tried to find out how many countries they have used. The number of them started to increase. I said that, okay, maybe it's not feasible to do that. And if you look at this picture, you see that we are looking for de-icing. As I mentioned, these systems can be used for another purpose also. And it's for warm climate. It's not for cold climate. It's for getting rid of the urban heat island. And if you can reduce the pavement temperature, because they can go up to, as we said, that we can use it as a solar collector. Sometimes if you have the black surface, you can get the temperature above 80, 85. And in some countries, they are more, the temperature is higher, then they are getting softening of the asphalt. Is another damage that they want. Then by using this kind of systems in a hot climate, you can reduce the urban heat island and furthermore increase the lifetime of your pavement. It is another application, and you can use that energy that you are harvesting, which is much more than the cold climates, and then use it for winter in order to heat the space heating or something that you need to heat up. Then the system has two sides, but we are focusing on the de-icing because it's one of our challenges in Nordic country and in the cold part of the other countries. The major question always is that how many kilowatt, because the initial cost, it is for itself, but how many kilowatt you need. And it is what we have tried to summarize there by looking at the different application. We have seen that this table is from Sweden, but the other reports from the state of the art, they are showing almost the same amount of the energy, depending on what you want to do. If we want to get rid of just the snow or the ice in the surface, you can warm up it with a couple of degrees above zero. But if you want to evaporate everything, then you need 5 degrees, which means that by increasing the temperature, you should pump out more heat to the surface, and your supply temperature from hydronic system increases. But roughly, no matter what you want to do, it's somewhere between 20 to 250 kilowatts per square meter. And in the beginning, it seems so that, oh, it's too much because the price of the energy is high. Yes, it is. I can tell you that in the United States, they are using electrical cables, and some people believe that it's a kind of luxury to have it in front of the malls and markets. But it is what we are trying to do, to use harvested energy. We are not using electricity. Then what I have here is a kind of indication that this system have been used in Arlanda Airport in Stockholm. And they are showing that what they need for de-icing, it's the parking of the airplanes, and what did they get with harvesting. And you see I have a lot of energy. Yes, you have, but you are losing a little bit because of the storage, seasonal storage. But anyway, you can manage to get all energy that you need by harvesting energy from the surface. And still, I can mention that in Sweden, at least in Sweden, we have 640,000 square meter that they have been heated by cables. The energy is the same. I mean that the energy that you need is the same. It's between 200 kilowatt per square meter. You are paying for that. It is what we are going to tell you that, okay, you don't need to pay for that. You can do it by harvesting energy. Then the market growth, this picture is this picture that you see here. I try to get it's a company that they do this. The market grow in all type of the businesses, but they want some huge amount of money to give this to me or to us, but they promised us to give us something that we can use. And they have done it for the icing system and melting the icing system. Here is about they don't think about the hydronic systems. They are just thinking about the things that is existing. And they have seen that between 2016 to 2022, the market have been increased by about $2 billion United dollars. It's about 6% increase each year. But here we have something else that is more visible. We got these values from Germany. When I'm looking at the state of the art of the Germany, it's more clear that you have an increase in using this kind of the snow melting systems. And it's not so, it's very impressive that they are using more and more. It is what I want to tell you. It's increasing market, and they are using, and they are trying to optimize. They are trying to use different type of the energy, especially heat, in different forms. I mean that if you are close to industry, if you have a kind of computer servers enclosed, then you can use all type of heats you can combine in a hydronic system. It's not depending on the heat source. It was the most part of not most part, maybe the keywords of the first work packages, but a lot of information is that about the environmental friendly and so on. We have written about that. But I believe so that these three, four points could be a good start to look at that, okay, what we have done in subtask 1. Subtask 2, if you remember, it's about modeling of geothermal energy storage and de-icing systems. Let's look at the system that I showed the picture from the beginning. We have tried to divide the whole system in 3 subsystems. One of the systems is the pavement. You should have your hydronic pipes there and so on. The other part is the storage. What you need is the control and coupling this together and know that how you should use that, what is the temperature that you should have, and if you can do a kind of weather forecasting, because if you send the heat to the surface, it takes at least, depending on the system, maybe 1 hour, 2 hours before that your pavement are going to be heated up to the temperature that you want. But if you have a weather station close to you and you can do a kind of weather forecasting, then you can start your system before that you know that they are going to be snowy. And what we are going to do, what we want to do that, is that to optimize the usage of the energy that we have stored here. And one of the questions that always is in the place is the backup system is needed or not. Because if we miss a number of times, then the energy that you have inside your storage is not enough to get rid of what you want. Maybe a snow, but the icing you can do, but not snow. Then if you don't do this kind of optimization, then you need a backup system. And this backup system could be any type of the boiler that you have or something else. And we don't want it really, but if you want to be 100% sure, then you should have a backup if your calculation shows that maybe in many cases you cannot do it. You help the energy that you have, because the amount of energy is not important in your storage, is the temperature level that you have. Maybe you have a lot of energy, but they are low temperature. You should increase the temperature to the one that you want. And this kind of stuff needs a kind of modeling. Each part, when we are looking at the existing modeling softwares, exists for any type of the boreholes. You can find it. You can find anything, everything about the pavement and how you should design that. But coupling these together, and then the control system, what it should be for optimization, it was the challenges that we tried to solve. And what we have done here is that our group in Italy, they have tried to see that in reality, where is what people have done. In this picture, you see that we have some prototypes in different countries. One of them is in Sweden, I believe, so that they have marked there also. It is what I showed picture for you. And some other countries started to do simulation, numerical studies. You see that the number of them is maybe more than prototypes. And real cases that they have is the green ones. And by looking at them and to see that how they have done it, they try to find out the challenges and softwares that existing for doing this. Some companies also, I'm just informing that they have already do everything. I mean that they do your calculation, they design your system and so on and so on. And they are existing in Germany and in other countries. They have a number of names you can find in our report. I don't want to mention any company now. But the challenges generally is that how you should treat the surface temperature, because you want to know that what is the surface temperature in order to send your heat to the surface. And this surface temperature is so complicated because it's have been influenced with a number of all the outside climate parameters. For instance, if you have the snow and a windy, then maybe a snow is, if you calculate for 4 centimeters, it's not 4 centimeters because windy condition there can reduce that in one part and increase in other part. All of this makes the calculations a little bit, itself the calculation is there, you have all parameters. However, the more you have, the more complicated the calculation becomes. And then you should, maybe you cannot cover all situations. But we have tried to show that there is a number of softwares and challenges, not challenges, but what you can do. And then the furthermore is the slush. When you have melted down, what happens to that? In other cases, we have talked about that when we are modeling here, we are not thinking about the cars that they are passing through. If they pass through, then the snow are going to be compacted. And they are helping to melt the snow also. And how that part can come in. It is things that we can add, but still we are not doing this. We are doing that. We are saying that when we are calculating this, it's a night, nobody passed through, and it is your condition. Because the other conditions that we are thinking about are going to help you to reduce your energy consumption. Yeah, it was about the work package 2, and you can find a lot of assessment about the different software that have been used. We have not a kind of commercial software that they can do just this one. And they have used different softwares in order to couple them to each other to see that how it works. Then these couplings between different softwares, and sometimes in Sweden, when we did the prototype in Östersund, we created our own codes, and then we validated that because we know that now it works with our system. We have subtask 3. Then we have here something that maybe is important at how we can develop that. I'm going to show some of the developments. If you look at this picture, you have the pipes, you have the asphalt, you have the storage, you have the weather condition, and so on and so on. There's a number of components that are going to be involved in this, and each of them could be improved in order to match to this system. Not for the whole road, but for this system. And I'm going to take some of them. Is, for instance, the thermal development of the heated surface. What we are talking about here is that to increase or decreasing of the thermal conductivity of the pavement. It is possible to reduce the delay or the time lag of when you are sending the heat to the surface. Then it becomes much faster because pipes are in the beneath of the pavement, below the pavement. And if the heat capacity of the asphalt or pavement is low, then the heat are going to pass through much faster. This kind of development in asphalt, they have started in Belgium, and they're looking at that. I think it's possible. But we have other kind of problems because if you do this or that, increase or decrease, then you are getting another phenomenon, another type of the condition. It is good for heat transfer, but maybe you are going to get more ice formation because the surface is very low, has the low capacity, thermal capacity. Other things that we have done is that trying to see that how we can, in order to, when we have this heavy roads, I mean that when you have lorries and so on, then it's very important that the pipes are not going to be delaminated from the pavement. Then how we can increase the addition between pipes and the pavement. And furthermore, if these loads are there, how the pipes behave. And what we have seen that pipes itself, they are not going to be damaged by the loads. They can withstand higher loads than we have had in roads, but still we have done it measurements to see that, okay, what's the space of this, what the distance of the pipes from the surface should be, and so on, in order to guarantee that nothing happens. The one that I like more is that how we should space these pipes. That becomes much more efficient. You see that people have done it in a very innovative way. Sometimes it's a more mechanical way that they have outside. But this kind of the solutions that they are showing here, it seems so that it could be a kind of solution that for future. But what we have done in our prototype road is that we never had anything like this. We have just put it on the beneath of the asphalt after compaction. But this kind of development that each system could be developed to the better way. I have seen that in one country they have produced prefabricated systems, which means that the pipes is inside, the road is there, pavement. Don't say road, pavement, and they are coupling the pipes together. And it is a kind of prefabricated hydronic pavements. Furthermore, we have looked at the distance of the piping from the surface and between them. And it's very obvious that you can see that if the distance is high, then the temperature is high, the distance between pipes, or the distance to the surface. Then to finding out what is the good thing and to optimizing that is another development could be done there concerning the pipe material, how good it is, because the pipe itself is plastic. It's going to show a kind of resistance that we don't like when we are sending to the heat to the surface. So I believe so that the time is running. Then I am showing the work package 4. In work package 4, what we have tried to do is that we look at all is a kind of mapping, all the state of the art that people talked about, that what they have. We have tried to map them to see. This map you see in Sweden is from Sweden. We have for Germany and other countries that they have delivered the state of the art. And you see that when we are looking at the Sweden, you have a kind of using electricity, using hydraulic pavements. Sometimes they have used district heating. Sometimes they have used geothermal. And this geothermal is based on the different type of they have used different type of the storage. For instance, Arlanda is here. We use boreholes. Sometimes they have used the ground source heat pumps, and sometimes groundwater. Because if you are close, your bridge is close to this, always is almost close to water. The water temperature is at 10 meter below is good enough to de-ice your bridge. And then furthermore, we have looked at what they have reported for the number of the kilowatts that you need to get off the ice and the snow. And it depends on that where you are in, what is your position in Europe or in the cold climate. What we have done in Östersund in Sweden, we get the most cold area that we could have in Sweden. The worst case that we have always a snow a number of meters. And then we try to get rid of that. Then Subtask 4 have tried to give design guidelines that sometimes we have used design guidelines from the companies that they are doing this, that how you should do the piping, what is good, what is bad, what is the distances, should do the insulation below the substrate or not. And furthermore, we have tried to give some kind of the not recommendation, suggestion how you should control the system when the temperature, surface temperature versus the outdoor temperature. You can have this kind of set points that when the temperature is below something, that you can decide that your system is starting to send the heat to the surface. And this could vary, but it is what we have used in. We have seen that they have used in many cases. That if you look at here, the outdoor is -12, and the temperature, the supply temperature, the set point is 10. Then after that, you can reduce that. And finally, we have given some kind of construction practice that if you look at here, our system, that how they should do it, and our storage. And we are showing again that how you can use this kind of additional substrate to have the piping and sensoring, that how, and our recommendation is not recommendation, that informational recommendation that you need these sensors in order to control the system. Yeah, and finally at the, I don't know if it is 4.3, I believe so, that we are getting recommendation to the market and technology, how we can develop these systems in order to make the transition. You see that this picture is from France. It's a real case that they are using. I can mention that is an unsuccessful case. Also, not this one. They have another one that they call it for power road. It's from the same project, but they have another idea somewhere that didn't work. They used the solar panels, real solar panels on the surface of the asphalt, and it was not so successful because they have tried to do a number of things. If you look at the reports, you can see that there is a number of systems and innovation that people have tried to do. And I believe so that it's my last picture. Thank you for your attention, and I'm ready to answer if there is any questions. Thank you.
So my question, my first and to be honest, only question that came up, because it's very clear actually.
Yeah.
I saw that in your list of examples, what you did, you had tunnel entrances.
Yeah.
And I was wondering, like,
why?
What's the problem there?
Yeah, the problem with tunnels is that you are changing the lighting. I mean that the light, you have the before, and then you're entering to the tunnel, it becomes the deviation there is so big that they have seen that a number of accidents happens in the entrance of the tunnels.
All right.
And
Yeah,
because
that
of that reason, the road, there is a lighting in addition to the road condition.
that makes
You're
sense.
entering from an icy or snowy condition to a kind of non-snowy because there is no snow.
Hmm.
When we are talking about the tunnels, you can think about the bridges also. When we are using the icing for bridges, because for bridges you have in both sides is the cold climates. When we are having a road in the below is the ground. In there, the risk for ice formation is higher, but people who are working with the traffic safety and so on, they are talking about that. Okay, if you are going from the snow icy condition on a bridge, which is heated, fair enough, good, but you're this kind of boundaries creating another kind of problem for the driver.
Hmm.
But it's not big, but they are talking about that, okay, these conditions that you are changing the condition for a very short time are
Hmm.
going to create problem.
Will always be a problem. All
Yeah.
right, that makes sense. That does make sense. All right. Anyone else? Any further questions? Still, and just, raise your hand. Just ask. All right.
But for me, that as I mentioned, that
Ah,
as you know, that the number of the we have done it as for a long time, from 2012 to 28 years. We have worked with the subject. We have collaborated with different road administrators. But what pop up that I showed you in the one of the pictures is that the reducing this paper, I like it very much. I can show you that one. This one, the injury reduction effects.
mhm.
It's very, very good because you see that they can calculate at how much you can gain.
Yeah, and I think
You
that's
know?
just something you easily forget.
Yeah,
This effect, as you said, it's just something you don't really think about that because you're thinking so technically when you're
yeah, sure. And
um
especially for elderly people, because during the winter they don't go out because of they are afraid of become injured. And
yeah,
what happens is that the life quality of this type of the society, this type of people in the society, are going to be increased.
will
They
increase.
dare to
Yes,
go out.
clearly.
Yeah,
That's
and this type of things we are as engineer just focusing on engineering and the
yeah,
pipe distances, pipe materials, heat capacity here and there. When I started to come in contact with this guy, I said, "Oh my God, we forget a very huge social problem
yeah,
that we never. It is costly for society when they become injured, no matter the ages. But the other part that they dare to come out during the winter time is
hmm.
another issue that you are improving
Yeah, it's
uh,
big
life
social
quality of the
effect.
society. Yeah.
Yeah, that's clearly. I think we do have a question.
Uh, yes,
Yeah.
hello.
Hello.
My name is Ben Yi, and I'm from Surrey University in the United Kingdom.
Yeah.
And it's a very great presentation. Thank you so much. And we're trying to do something quite similar, a field trial with the
Mm,
local road authority. And one problem we face that is the road authority is quite reluctant to try this kind of new technology on their pavement, especially the utility team, saying that they have the pipes utility in the subgrade. So oftentimes they need access to dig a hole on the pavement. And if you
mm,
put some pipes in the asphalt layer, they're
mm.
worried that if they dig up the utility to repair them, they're going to damage your pipe, and you've got water and sometimes more than water in the pipe. They're
Yeah.
worried about all this like kind of damage. How did you like convince the road authority
Yeah.
to do that?
The one that we have discussed with at least two, three road administrators, because the project that we had uh, was a kind of collaboration between it was a number of different. partners, but a part of the budget comes from 3 road administrators from Scandinavian countries, Norway, Sweden, and Denmark. And they had this question. But if you look at that, how we place that, generally replace 1 or 2 centimeters from the surface, the top layer. And these pipes is below that. And the damages that can cause because of the water leakage in the asphalt, we haven't seen any water leakage because the pipes, they have already been used, and the company who delivered this, they guarantee that nothing happened. But what you can get for leakage is outside of the asphalt. When you are coupling your pipes to the pipe comes out from the asphalt, and by coupling that to something that goes to some source at the storage, in that coupling you have seen leakages, but it is outside of the asphalt. It's not inside of the asphalt. And it is the thing that we have convinced them that these systems are working already now, but you are using some cables, electrical cables. And they have, I don't want to mention the name of the companies. You can send me an email, then I can show you that they are guaranteed. They have used it in, and something that I forgot to tell you is that ASHRAE in United States, they have used this and they have a standard for that. And in very soon, 226, they are going to have a meeting about this. And the reason, the motivation is that when you are using the cables, they are talked about the luxury, it's a kind of luxury. But if you show that the cost is not too much, then you can use it anywhere that you want.
Right.
And as I said, for instance, we have these pipes by district heating. The heat source is district heating in a road part in Sweden. It's about, I believe, so if I remember correctly, is about more than 1 kilometer or 1.1 kilometers in a slope. And they have done it for 16, 17 years ago, and nothing have happened. And if you compare the climate in Sweden and in UK, we should be more careful about if we got a leakage, because are going to frozen immediately.
Yeah.
And nothing has happened, and they are happy. But for them is that they are sending the return temperature. The cost is almost nothing, because the return should go back to a plant in order to cool down the return temperature. And you can look at that. If you send me email, I can send the links that they have done for a long time ago. They are working. It's not leakage in the surface is not usual inside the surface, but outside of that, yes, we have seen that when we are coupling to the other type of pipes, then you are getting some problems.
Yeah, thank you so much.
You're welcome.
Email later, definitely.
Yeah, no problem.
Yeah. All right, that's one more interesting detail. Anybody else? Any other questions? Because if there aren't,
I can add just one thing more that maybe
please,
good for the people from asphalt side, is that when you are using this kind of the pipes, the estimation that have been done is that generally you repair your asphalt after 10 years. We have done, I don't remember where, but we have done a kind of estimation. If you use this type of the pipes, you are going to increase the lifetime before reparation to 15 years. You don't need to change it, because the asphalt are going to be damaged because of the heat expansion and contraction, and you are not going to get cracks and so on. It's the advantages that you can get, but still, you have your concern is correct.